So good afternoon. Welcome, everyone. Thank you for taking the time today to come and learn a little bit about Tableau Online architecture. Before we introduce ourselves, we'd like to get to know you a little bit. So how many of you are existing Tableau Online customers? OK, quite a few of that. How about server admins wanting to learn from Tableau Online? OK, good number there. So let me introduce you to my partner in crime, our Director of Product Management, Kitty Chu. She's been with Tableau about 4 years. In that time, she's led our strategy for Tableau Server. She knows a lot of you because she's had long conversations about Tableau's products with you. And this year, she joins us to help us evolve the strategy for Tableau Online.
Thanks, Pratik. And I'll just say a few words about Pratik. Pratik has been with Tableau for 5 years. He started out on the desktop team. And just as we were getting serious about building a SaaS product in Tableau, he joined Tableau Online. And he's been with the team for the last 4 years. You could even say he's kind of a dinosaur of Tableau Online. He's got a lot of great historical and institutional knowledge about how Tableau Online has evolved over the years. So I'm really excited to have him as my co-presenter.
Thank you, Kitty, for that very kind introduction. When we talk with many of you, these are the kind of themes we hear is that, how easy it's been for your Tableau Online journey, how easy it is to create the account, add users, grow your account, and actually drive engagement with Tableau Online. And so we also know that many of you are very curious about how Tableau Online works, how we run it, why you should trust it. And so today, Tableau Online is actually our fastest growing product. And so today, we'll be able to take you on a journey to understand how Tableau Online works and hopefully answer a number of those questions. And with that, I'll hand off to Kitty to get us started.
Thanks, Pratik. So yeah, what are we here to do today? We're going to look under the hood of Tableau Online. We'll peek behind the curtains, and we'll show you a little bit about how we deploy and run Tableau Online as a service. I'll start by giving a pretty high-level overview of Tableau Online just to familiarize the audience with Tableau Online, and then we'll start talking about how we do our topology. We'll talk a little bit about deployments in Tableau Online. We'll talk about some of our shared services, as well as how we monitor Tableau Online, and also how we use Tableau Online internally to run our engineering business. I just wanted to make a few kind of comments. Feel free to ask questions along the way. We're happy to take questions. Just raise your hand. I'll try to accommodate those as we go along. But we also have plenty of time at the end to take questions as well. And a reminder, this is an advanced level talk, so we will be talking about some of the server processes, and hopefully all of you are a little bit familiar with Tableau Server. But if you aren't, don't worry. We'll kind of walk you guys through it slowly. All right. So to get us started, I just wanted to demonstrate the global reach that we have with Tableau Online today. We have over 16,000 customers all over the globe that are Tableau customers today. They connect to one of our 7 production pods, and we're looking to continue to expand this through next year. So let's talk about Tableau Online, by the numbers. I mentioned we've got 16,000 customers today, and we have 300,000 users with over 500,000 workbooks and 1.6 million data sources. In a typical week in Tableau Online, we run through 2 million workbook views. We have 180,000 published activities and 250,000 subscriptions. So we're talking about pretty large scale service here. Next, I'm going to talk a little bit about security. Security is top of mind for customers that are in Tableau Online. And we want to make sure that you understand that we take security very seriously. We are protecting all the data, so any of the permanent data stores, as well as all the EBS volumes that we have within a pod, are encrypted at rest by default. We also have encryption in transit, so all our inbound communications are encrypted with TLS. For outbound communications, for example, if we need to connect into data sources that you may have hosted on-prem, we always recommend that the customers also have TLS enabled so you have that two-way security. And then because we are hosted in AWS, we are able to leverage a lot of the capabilities provided by the public cloud. So we leverage their VPCs, we have security groups established, and we have access controls to make sure that we know who's accessing things within our production pods. We also have SOC, SOC 2, and Privacy Shield certifications. And we're always doing external and internal assessments of our product. We do a yearly external audit of Tableau Online specifically, but we also, for any new features that are getting developed by the product team, those go through rigorous security reviews before they're allowed to release to production. If you are interested to learn more about Tableau Online and security, there is actually a whole talk on this tomorrow morning. It goes into it in a lot more depth. So definitely check that out if you have more questions about security. All right, so moving on, let's look at what's inside a pod. I mentioned there are these 7 pods that a customer can connect to. You know, this is a bit of an eye chart, but don't worry, I'll walk you guys through this kind of step by step. So the first thing I'll talk about is the Elastic Load Balancer. All the inbound customer requests come through this ELB, or Elastic Load Balancer. The way that we have an online pod set up is that we have availability zone 1, which I've highlighted on the left, and availability zone 2, which is highlighted on the right. They are mirror images of each other. One of the great things that this design or this architecture gives us is high availability or redundancy. In AWS, zones are designed to be redundant. So each of the availability zones run in a separate data center. They run on separate power. So if we were to lose one availability zone, there's a very high likelihood that the other availability zone will still be up and running and can continue to service our customer requests. There's kind of a special case with the file store and repository that I wanted to call out. There's only ever one instance of file store or repository that's running actively at any one time. So both of the services across both AZ1 and AZ2 will be connecting to that active repository and active file store. We have streaming replication set up to a passive instance of repository and file store running in the other AZ. So in this case, AZ2. So if we were to lose AZ1, or if the repository or file store were to go down in that particular AZ, we could easily fail over to the backup, and things would continue to run smoothly. Any questions about this so far? So the question was, what's the frequency of the sync? So that sync actually happens, it's streaming replication. So it's actually happening all the time in the background. Yeah. All right. So now I'm gonna zoom into one of the AZs because they're mirrors of each other. Then we'll talk about how we've kind of divided up the services inside that pod. There are 3 layers that I'll talk about. So the first one is our front-end application services. They handle all the ingress and egress for the pod. Next is our middle tier services. They handle all of the heavy lifting of the processing of the queries, as well as any of our background or scheduled tasks. And then finally, the backend services. They really hold all our persistent data, as well as their management and infrastructure layer. All right, so let's dive in. We'll take these one at a time. In our front-end layer, the first service we have is our HA proxy. So the HA proxy is responsible for load balancing traffic to the rest of the application workers within that particular availability zone. If you remember back to my initial diagram, the ELB is where all the incoming traffic comes through, and it will load balance the traffic to one of the 2 HA proxies, one in each availability zone. The other thing that the HA proxy takes care of is sticky sessions. So once you as a customer have a session open, you're browsing a viz, the HA proxy will know how to redirect any future requests back to the same application worker. That way it can leverage things like caching and et cetera to make sure you have a good experience with Tableau Online. Next is the application worker. This is really the workhorse of Tableau Online. So it handles all the user traffic and interactive traffic of Tableau Online. Anytime you're searching a viz, you're doing a web authoring session, you're exploring, you're doing, everything goes through our application workers. And then finally, we have the bridge connectors. And that is for connecting to any data sources that you may have hosted on premise. In order for this to work, you as a Tableau Online administrator would need to deploy a bridge client within your organization that will set up that link between your organization and Tableau Online. And this is how we handle both live and extract queries to data sources that may be hosted on premise. All right, now let's move on to the middle tier services. So the key one here is our background workers. They run all our extract refreshes, subscriptions, alerts, et cetera. One of the unique things that we've done in Tableau Online is we've divided them into 5 distinct roles. So we have a set of backgrounders that only runs extract refreshes, a different set that runs subscriptions, et cetera. What we found is that this allows us to optimize our workloads and optimize scaling for those particular workloads. For example, subscriptions tend to run a lot quicker than extract refreshes. And by isolating subscriptions on their own backgrounders, they don't get backed behind these long-running extract refreshes. We can go through them a lot faster. Next, we have the data engine. This is also known as Hyper. It's our fast analytical query processing engine. In Tableau Online, one of the things we've done is we deploy them on their standalone server. You may have heard of the term HOS, or Hyper on a standalone server. So this is how we have it deployed in Tableau Online. Again, this allows us to isolate and optimize those query loads, let Hyper really use the full capacity of the hardware that we have given it to run through those fast queries and make sure that your vizzes are loading quickly and performantly. And then finally, we have some new services with Ask Data and Tableau Catalog. So Ask Data shipped earlier this year in 2019.1, and Tableau Catalog shipped in 2019.3. So this is a pattern that we're starting to do with our new services, is to deploy them in their independent services, or what we call microservices. This, again, allows us to scale these services independently of the rest of the Tableau Online pod. And so you might be seeing more of this as a pattern moving forward. Any questions so far? All right. Last but not least, we have our backend services. So the repository, it runs on a managed instance of RDS Postgres. Because it's running on a managed instance of RDS Postgres, it allows us to scale that dynamically as we grow our pods. It's also highly available and just very reliable. We also have a network file storage, which is replicated, as we mentioned earlier. This is a little bit different, again, if you are familiar with the Tableau Server product on premise, which we have file store nodes. In Tableau Online, we don't run with file store nodes. We run on this network attached storage. And all the services across the pod are connected to this shared instance of the file storage. With both the repository and file store, they really are what make up the persistent data within a pod. So we have things like automatic failover setup and replication, and we make sure in online to back up that data every 24 hours and ship it to an off-site location so that we keep that data safe. I'll just put in a quick note here that for both running RDS running the repository on Amazon RDS, as well as running the file storage separately on a network-attached storage. Those are capabilities that we are bringing to the Tableau Server administrators who are hosting in AWS as well. So those are part of the server management add-on, and if you have more questions about that, there is a talk tomorrow morning about that as well. for those of you that are interested. And then finally, we have our Solar and Zookeeper nodes. They kind of keep the service running. We have 3 of these instances across the pods, and that allows us to have quorum. And that kind of rounds us out. Any questions before I move on here? Yes, Mark?
Do you have ideas of Firestore size? Just curious. Backup, how long it takes?
Not a few hours. Because we work with on-site location. It does take long.
Yeah, but we do run on the network attached file storage, so I think we do have the snapshotting capability. Yeah. All right. So next I wanted to talk a little bit about how we deploy to Tableau Online. You as a customer may or may not know that we actually deploy a new version of the product to Tableau Online on a weekly basis. We're always making small tweaks or making bug fixes, and we're able to do this with very little to no interruption to you as a customer. We also do, of course, major quarterly releases that are aligned to our 2019.3, 2019.4 releases. So you probably are asking, how do you do this no downtime upgrade thing, right? All right, so I'm gonna show you how it's done. All right, so to do that, I'm gonna introduce a new component called Hosted Commander. Hosted Commander is our kind of orchestration service within Tableau Online. It's very similar to Tableau Services Manager in our on-premise product. It's what coordinates our deployments. So the first step of a Tableau Online deployment is something we called applying database migrations. What this means is we're actually upgrading the database schemas to the latest version of the Postgres schema for the new version of the product. But one of the things we do in our product team is we always make sure that when we run those database migrations, they're backwards compatible with the current version of the product. And this is actually the key piece of what allows us to do no downtime upgrades. Even after we've upgraded, we haven't upgraded anything else, everything's still running smoothly because it's backwards compatible with the current version of the product. So now we're ready to start the rest of our upgrade. The first thing we do is we're gonna go and pause the backgrounders and start to upgrade those first. And this is where you, as a customer, may notice some delays in your extract refreshes or subscriptions. The entire deployment process takes about an hour, and so that's about the amount of delay that you might notice as a customer. So once those backgrounders are upgraded, we can start and go ahead and upgrade the rest of the pod. Now, one of the things we do is we leverage the fact that we have deployed into availability zones, and we upgrade half of the site, half of the pod at a time. One of the things so the first thing we'll do is actually disable the traffic going to AZ1. So that Elastic Load Balancer stops sending traffic to the HA proxy in AZ1. It's only sending traffic to the HA proxy in AZ2. Once the traffic has drained off that pod, we can go ahead and upgrade the services in AZ1. Now, all this time, the traffic customers who are logging into the service, they're still being able to see their vises and everything's working smoothly because they can still connect to AZ2. And we monitor our traffic very closely, and we know that when we're doing the deployments, we have enough capacity built out in the pod that we can take out half the pod and still kind of run smoothly. All right, so now the services have upgraded in AZ1, and now we can actually flip it around. We can go ahead and re-enable AZ1, so Elastic Load Balancer is sending traffic to AZ1, and we're now not sending traffic to AZ2 and letting the traffic drain out of that availability zone. And the same thing happens now. We'll go ahead and upgrade those services in AZ2, and once they get upgraded, then we can re-enable AZ2, and now we're back to full capacity in the pod. And then the last step is, of course, to re-enable those backgrounders across both AZs, and deployment is complete. Any questions on that piece? Yes?
So when you say that you pause the background for 1 hour, so what happened with the extract? Because I believe there are some certain timeouts as well for those extracts that doesn't get triggered, right?
So any jobs that are in progress on a backgrounder, if they don't finish, they're still sitting in the queue in the Postgres database. And so once we re-enable those backgrounders, they will get picked up again and rerun. Yeah, so we do try to avoid peak times when we do deployments to not cause a lot of interruption to traffic. But we can definitely talk more offline after the talk about your specific scenario. Yes?
First way out of the way, step one, is there any downtime at all?
No, that's transparent to the customers. You can just apply those kind of dynamically. Yeah. All right. Well, with that, I'll actually hand it off to Pratik, and he will talk about our shared services.
Thank you, Kitty. And so in 2013, we launched Tableau Online. But at that point, the product that we had was Tableau Server. And so to make it possible for Tableau Online to exist in the cloud, we had to create a set of shared services which allow you to provision your site, to be able to sign in and things like that. So I'll get into the details of how those things work. So Kitty went over the chart that you see on the right, and then she also covered a little bit of the hosted commander piece, which is right on top. And then, so let's say you become a Tableau Online customer. The first thing that you come in contact with is creating a site, right? And so we have a set of services which handle all of our provisioning workloads. When you convert a site from, for example, trial to a paid site, that's where provisioning happens as well. If you have other entitlements, they are also handled through the provisioning services. The next thing that you would do is log in. And sign-in is critical to any SaaS service, and we want to ensure that you are always able to sign in. So we've designed our sign-in services to be globally redundant. And so even if any region of AWS is down, you should still be able to sign in because we have multiple regions in which sign-in exists. And once you sign in, we need to send you to your instance, right? So your site and pod where it exists. And so we have a multi-instance service which knows about all of our customers and is able to redirect traffic to the right pod once you log in. Tableau Online is a shared service, so we have many, many customers running across all of our pods. And so we want to ensure that everybody is able to fairly use the service. And so we have a governance service which puts guardrails to prevent abuse, any accidental abuse as well. But we set the limits extremely high, where most of the time, most customers should never see any throttling of their services. We also want to know how our product is getting used so we can actually build the next generation. And so we had a set of services which provide us telemetry at an aggregate level to understand how Tableau Online is getting used. And so we keep that in a secure storage so that we can actually look at it at an aggregate manner, and there are certain people who have access to that. And then finally, it is critical for us to monitor the system as it's running. And we generate a ton of log data. We generate tons of metrics. So we have a set of services that actually looks at all of this stuff and captures all of that for us. And so what do you guys think we monitor for Tableau Online? It's a SaaS service. We monitor everything, right? We are collecting about 2 million metrics every minute, about 2.5 million metrics actually, every minute from all of the different Tableau services. And so let's get into the specifics of the different kinds of monitoring that we're doing. So resource monitoring is the traditional old-style monitoring where you're looking at how the system is performing, right? So traditional things like CPU, network, disk space, memory, all of that stuff, right? So we're watching all of those. In 2003, Google created what was the precursor to DevOps, which was their whole SRE paradigm, where they talked about the fact that if you don't do anything, you need to monitor these 4 things for your service. And so those are latency. So you want to make sure how long is a request taking to be satisfied. So we monitor the latency of different kinds of requests. We monitor how much traffic is coming into the system. This is, requests per second kind of monitoring. We look at, how many errors are going on in the system at any given moment in time. And then we also want to know how much of our service is getting used, right? So we understand saturation, as in how close are we getting to the capacity of the service. So we can stay ahead before the service reaches its limit. And Tableau Online is not just any service, right? There are certain set of capabilities that it provides to customers, which customers really care for. And we want to ensure that we are monitoring that each of those capabilities is also available and performing at the level that we expect it to. And so we watch things like sign in, loading content, loading a viz, publishing, and things like that. So these are the things that customers care for, and we're watching a whole laundry list of these things. Let's take a look at how all of this monitoring works from an architecture perspective. So what you see is one of our AZs on the left side, and then on the other side is the set of tools that we use to actually provide our teams with all of the monitoring from these systems. And so you can categorize these into a few things. And so there is collection. So we have a set of services that are collecting from the system, and there's real-time alerting. Then the next thing that comes is escalation, and then finally, dashboarding and visualization to look at long-term things. So let's dig into each one of these to understand what things happen, okay? So for collection, if you're familiar with Tableau, you know that Tableau generates a ton of log data, right? Whether it be desktop, server, or online, we generate tons of logs, and a lot of our monitoring actually relies on logs being there. And so today we use Splunk to actually monitor all of our log data, to collect all of our log data from all the systems that exist. We've also instrumented our code base to generate metrics natively. So for our C++ code base, we have a ton of log data. For our Java code, actually that's generating metrics. And so we are capturing things like JMX metrics. The application performance monitoring is happening through those. There's end user monitoring. We can actually see how long it's taking for customers' requests from the browser, from their browsers as well. And there are custom metrics that we've put into our code base as well, which are all monitored using New Relic, which is a third-party service. And then we run 100% on AWS. So we use to monitor all the native metrics or resource monitoring, we use AWS CloudWatch. Now, once you've collected all the data, you want to make sure that the system is telling you. You're not watching dashboards all the time to understand what's going on with the system. You want to build capability so that we get alerted by the system itself before anything bad happens, right? Before our customers detect anything. And for that, for real-time alerting, we actually track all kinds of things. This is just a list of few of those. So we're tracking like what the error rates are. Are they going out of band, right? And so we'll get alerts on that. Response times, like what are our response times within bounds? Our services actually have notions of service health. So because are they able to reach downstream services? And if a service is, you might not see it in a request, but we want early warnings that, oh, something is going wrong with the service, so we have alerts on those as well. We also watch how much traffic is coming in. Has traffic dropped? That could be an indicator of something going on. Or if there's been a traffic spike, right? And you want to stay ahead of all of that. And things like, how is CPU, memory, that's infrastructure monitoring. And then there's random anomaly detection, like things that we're capturing 2.5 million metrics. If some of them has an anomaly, we cannot have alerts for every single one of them. So we can do generalized anomaly detection on some of those as well. And so once we've got all of this alerting in place, let's say an incident happens, which is not automatically remediated because we've built capabilities where if something happens, then do this. So we have automated some of those things, right? But we can't automate everything, and there are new things that are happening with the system all the time. So we want to make sure that some of our development team can be reached before anybody has noticed a problem. And so for escalation, we use PagerDuty and Slack. We also want to make sure we understand how long-term trends are with our systems, right? So some of the alerts might be saying that we have reached 70% of capacity on a certain service or a resource or something. So that the team that built that thing is aware and they can do the long-term planning. It's like, okay, at 70%, we want to add more capacity or look at how the system's behaving. Is there something else going on with the system? So that's for long-term planning as well. And then finally, when an incident happens, or there's a bug that happens, we want to make sure that we have captured everything that our development teams would need to understand what happened at any given point in time. So they can look back in time, because there's nowhere for us to go capture things in the past. And so what we do is we do deep analysis using Tableau itself. We actually have various visualizations built on Tableau Online itself. And then we also use New Relic Insights for that. We also use all of this data. We capture this data and we store it in Snowflake for the long term to look at long-term trends for various things. And you can look at, oh, something's happening right now. Was something like this happening last week or last month or last year? Because there are trends that can be seen that happen year over year, but you might have forgotten. So we have long-term trending available so we can look at those things. And this also allows us to actually plan for future growth, as in how our service usage is growing and how do we stay ahead of the curve there. I wanted to show you one of our visualizations that we use internally to track our availability. This is from one of our dog fooding instances, which we call Alpo-dev. We'll get into it in a little bit. But this shows the things that I talked about. The scenarios, the specific scenarios, you can see them on the left, which is browse content, load a view, and how availability is running for each one of those scenarios. And so this shows a two-week chart of how that's been trending. But this is from our dog fooding instance. This is not from production, the specific data here. And so let's get into what dog fooding is. Some of you might be familiar. But in the 70s, Lorne Greene actually had a dog food product, which he used to call Alpo. And to show the quality of the product, he used to feed the same product to his own dogs. So that's where the idea of Alpo comes from. And since we like to run our software, our product ourselves to run our own online business, we call it Alpo-dev. And so Alpo-dev is really the business of developing Tableau software using Tableau software, and specifically Tableau Online. So Alpo-dev actually is an instance of exactly an online pod. Like how anybody would have a site in online is exactly how we run our business. We have a site, it's a production pod with everything production-like. It's set up in AWS, and so we run everything there. And so the kinds of things that we do there is, we are tracking our bug metrics, we are tracking performance, scalability, we are looking at different engineering metrics, we are doing testing through that, we are using many, many different connectors in there to make sure that it's a production-like instance. So to take a quick look at, what is Alpo-dev like? Like how is it like a production site? So it's a 6,000 user site. So every single employee of Tableau has access to this site. It's set up using Skim, which is currently in beta, but allows us to do group management. And you can do things like, okay, create your creators, explorers, viewers as groups using Skim, and then it just syncs through that. You don't have to manage them inside Tableau. You can do it at your single sign-on provider. And we use single sign-on using Okta. And then I mentioned all these connectors. There's a laundry list of all the different connectors that our development teams, our employees are using every single day through Alpo-dev. Now, one of the things that is true is that although the world is moving to the cloud, there is still a ton of data on premise. And that's true for us as well, right? And so with Tableau Online, you have the Tableau Bridge product, which you can use to connect to your on-premise data. So in our Alpo-dev environment, we actually have an instance of 115 different bridge clients that run, which people use, which are shared instances, which we use to connect to our on-premise data. And so we are using these for live connections as well as running extracts. And the bridge service actually releases every month, and so we get that every month and upgrade every month as well. And here's a quick look at how big Alpo-dev is in terms of capacity of hosts, of how different workers and backgrounders and hypernodes are. We have 31 total hosts. There are 2 different RDS instances, just like in production. And we have 2 network file storage server instances, which Kitty spoke about, the active and the passive nodes. So it's exactly like production. And here's kind of the workload that we see every single day in Alpo-dev. We have about 520 different projects, about 2,500 different data sources, about 8,000 workbooks, and we see about 35,000 views every single day. There are about 10,000 logins that we see every single day. Some of these are automated, some of these are by our employees. And I'm sure you have such these scenarios as well. And then about 20,000 publishers. And so Alpo-dev deploys weekly for us. It gets alpha quality builds, and we run all of our development business using Alpo-dev today. It helps us with things like early detection. So if there's bugs in the system, we detect them early, and we're able to fix those. We actually do performance testing through that because we have a large amount of load on this system as well, and we can see scalability of the system as well. We've actually, for example, when Ask Data actually was initially launching, we initially launched it to Alpo-dev, and the testing there revealed that there were some queries which were running long. And so we fixed those things, and that problem never made it to production. One of our core values at Tableau is using our own products. And so while all of our employees are using our products, they're also very passionate about interactivity and user interfaces and things like that. So we get a ton of feedback from them as well when the first versions of these products makes it to Alpo-dev. And we get real-world usage data on how our product will perform while in a production-like environment. And that brings us kind of to the end. So Kitty today actually went over the internal architecture of a pod. She talked about security. Then she went over our deployment processes, how deployment happens. Then I covered the shared services and how Tableau Online has become possible. And then we went over all of the monitoring systems we use and what do we monitor and how do we do it. And finally, we took a look at how we run our business using one of our production instances. Before we finish, I would like to show you some related talks. So if you're more interested in security, you can go to that talk tomorrow. If you're interested in the server management add-on, there's a talk about that. And then if you're interested in how to understand what's going on with your Tableau Online instances, there's a talk about that using admin insights as well. And then the next thing, it's critical for us to learn from how we're doing. So please make sure you fill out the survey before you head out today. And with that, we're happy to take any questions.